We welcome all the participants and guests for the third session of second day ATAL Faculty Development Program on Mode of Communication During Disaster. We're glad to say our today's guest, Dr. T. Palnichami sir, Professor of National Institute of Technology, Karnataka, is our prestigious alumni, and we are very happy to invite you for this session, sir.
Yeah, thank you for a nice introduction. Again, I'm proud to say as alumni of SPC. So the continuation of yesterday's talk, I can continue. Then my voice audible now, I hope.
Yes, sir. Audible, sir.
Yes, yeah. Minute, I'll share my PPT. Please guide me 1 minute.
Okay, sir.
Yes, I can share. Okay, you can see my PPT full?
Yes, sir.
Full screen mode?
Full screen, sir.
It's moving also?
Yes, sir.
Yeah, fine. So again, welcome back to for the day 2 of ATAL FPB program. So very thank and acknowledge to SPC. So I want to continue. Yesterday we talked about the this topic, advanced technologies for the sustainable damage management through the SPACA as a replacement. So I quick through it 1 minute. So last session we discussed about that introduction part. What are the scenario of cement industry and the fly ash manufacturing? What is the geopolymer? What is the FACA? How to prepare the FACA? So what are the mixed proposals? So what is the patent? And how it looks like FACA? What are the mixed proposals using in that FACA manufacturing? What are the mechanical property? Then some elemental property. So how it looks like in scanning electron microscope in micro level. What are the interference we did in this study? Then what is the FACA-CRIT? So how we can make it the FACA-CRIT? What are the mix IDs? What are the grades used for this investigation? Then what is the property of concrete FACA-CRIT in the first stage, hardened state, with respect to the compressive strength, split tensile strength, flexural strength, models of rupture, relations between among the mechanical properties of that material. For example, split tensile strength, compressive strength, and X modulus, so on so, etc. And we last class we seen about that structural properties also, like a stress strain behavior, how it looks like, how does this FACA-CRIT aggregate, it's influence the stress strain relationship and elastic modulus. Then different graphical representation of stress strain curve also discussed. So very interesting topic also we discussed in the last class, the last presentation. That is the mode of failure, what kind of failure may be observed during the testing of the different grade of concrete like M20, M20 FACA, M25, M30 FACA respectively. Then non-district testing also we discussed. Then slip behavior of the FACA-CRIT, how its FACA-CRIT is maybe functionally with respect to that slip behavior. Then what kind of mode of failure you observed. Then bond strength. Then what is that interference we made using that bond strength. But also we had discussed the last class. Then here, then some empirical modeling also we seen that, right? Why is go for the 3 linear scale modeling, empirical modeling. We had seen that yesterday class. Then the behavior of FACA-CRIT in the beams, how it behaves, this FACA-CRIT in that in terms of structural elements like a beam. These things we discussed. Then what is the ultimate load? How it's compared with the ultimate load to the theoretical calculation. These are the things we discussed. These are the things we discussed. Then load deflection behavior. Then ductility behavior also we discussed, right? So up to this we discussed last class, is correct? So now I want to talk about the ductility behavior. So what is the need of ductility? What is mean by ductility? So the ductility is need of our Why? Because the zone is changing. The most of the places like Chennai, Coimbatore, Bangalore, and all those things. So now we want to find the new technology or the new material to withstand this existing load condition or new load conditions kind of things. So we need some new technologies. For that, so most of the cases we are talking about the earthquake resistant structural design concepts. So for that, the ductility is a very important phenomenon. So for that, we want to develop some new material or we want to examine this material have the ductile behavior or not. That kind of studies is like that. Basically, what is meant by ductility means what is the behavior of the material after the yielding, after the ultimate. For example, I can take one graph kind of things. This is the low deflection curve or stress strain curve kind of things, right? It's maybe buckle like this. So it's maybe feeling like this. This is a strain. This is the stress or load versus deflection. Del, assume this is del. This is the load versus deflection or this kind of things, right? So what is the behavior up to this, you know, all up to this is the elastic limit, this is altimeter, after that it tends to failure kind of things, this is kind of going like this, right? What is that difference, what is the behavior of this material or in case of any structures after this point, most probably after this point, on this point, what is happening kind of thing. Suppose this material, it behaves after this yield point, it's good, and after ultimate point, it's good. For example, I can take some kind of graph. It's like this. It's not good. Why? Because we have the no energy after that ultimate point. But you can see this graph. This graph, we have that huge amount of this. So how much energy you have after the yielding, that is called as ductility. So what is the use of this? So once you have the ductile, then only we can escaping from the building during the earthquake, or any kind of failure. No, sudden failure will not happen. So we have some enough time to escape from the building. For that purpose, you want to design the structures by the ductility. Then mathematically, how we can call it means. So this is the typical load deflection behavior curve, right? PU is represented as ultimate, then PU is nothing but a yield, right? The ratio of maximum deflection to the ultimate load, ratio of the maximum deflection at the ultimate load to the yield deflection at the ultimate load. Simply, we can call term as durability factor, the ductility factor del U by del Y, del U by del Y. Or else we can represent by load also. What is that? Deflection at that ultimate. What is the deflection at load? For example, this is a yield. What is the del Y? The ultimate. What is the del U? So the term ductility factor mu is equal to del U by del Y. So usually our last class also we discussed. So we can find this, what is the area bounded between these two? I can get the energy. I can get the energy. So if I have this curve in that wider in nature, I can get that very good energy and all those things. For example, I can have one graph that is in case of in case of plain concrete, it's maybe looks like this. Really looks like this. So now I want to calculate this area, this much only. If I go for that some kind of one second, some kind of RC. No, I can get in between graph. It's look like this, right? I'll go for the some fiber added material. Graphs looks like this. Fiber added material. So you can have the difference, no? First graph, second graph, and third graph. So among this, third one is good because of The energy is more. After that, up to this, no changes, that much changes. This triangle is right. So after this, we have a lot of changes. So the lot of research is going on in this particular area, how to improve again and again, and how can extend this maybe another level. This may be reference the ductility of the material. So if you may add some, if you add some fibers like a steel kind of fiber, it's improve the ductile behavior of the beam kind of things. So what we did here means, if I can change this aggregate, how it's improved or what are the changes happening kind of things we did. For that we can given here. The ductility factor is the ductility factor of the FACA is more than normal concrete for each grade. Increase of ductility factors M20, M25 FACA and M30 FACA is 4.01%, 2.33 and 2.05 percentage. Why? Because means this also is indirectly, I am not claiming exactly is contributing for the ductility, is indirectly contributing the ductility. Why? Because we are not changing that conventional concrete and this concrete, only changes the aggregate. So aggregate also slightly influencing the ductile behavior of the material. Why? Because this have some less density, the surface morphology, then interface between that steel reinforcement and concrete matrices and all, lot of factors influencing. This study we can claim that FACA grid, sorry, FACA also slightly influencing the ductile behavior of that. So these are the table is showing that this is M20 grade concrete, M20 FACA. The maximum deflection is given here. The yield deflection. From this we can calculate the ultimate ductility factor. So here not only these methods, is a number of methods, a number of theory also available to calculate the ductility of that number. Then another one is a deflection profile. So what is the use of the deflection profile means? The how it bends and how it looks like the profile with respect to different load also. For example, I can take 0 kilonewton. What is the deflection? In case of 10 kilonewton, what is the deflection? You can see this, how much is deflect. So why it's deflect more, why not it's deflect less. So these kind of informations we can learn. From this we can find that some fundamental properties also. For example, I want to calculate what is the moment curvature effect. That also I can calculate using this kind of study. The deflection profile. The deflection of the beam were obtained midpoint L by 2 and L by 3 from the left end and L by 3 from the right end. So 2-point loading, L by 3 distance, we measure that deflection. The FACA grid beams deflect less as compared to the normal concrete beams at the same level of loading. The FACA grid beams deflects less and compared to the deflect less means it gets a very good bonding between these two, and some mechanical property is very helpful for the reduction the deflection. Even though the ultimate load carrying capacity of the FACA grid is less, the FACA grid can replace with normal concrete also possible. Both ultimate load and deflection of the FACA grid can be comparable with the normal concrete. On increasing the grade of concrete, the deflection of normal concrete at particular load decreases the, while for the FACA grid, the deflection is increases. So this point we can conclude this. On increasing the grade of concrete, the deflection of normal concrete at the particular load decreases. For the FACA grid, the deflection increases. So these kind of things we learn from this profile. This is the deflected deflection profile of different grade of concrete. Concrete specimen M25, M30, FACA respectively. Then variation of load with strain. Variation of load with strain. So you can see this figure. NC is a normal concrete. Then NC is a normal strain of the different mixes. I given here the different FACA also, right? How does this load is transfer, or the different grade is given here. From this figure, we can learn all those things. So basically, we can take that concrete, no? We can take this x-axis, y-axis kind of things, right? So this is the tension zone. This is the full compression zone. This is the full tension zone. This is the compression tension. Then this is the tension compression zones kind of things. So most probably you can plot this the stress distribution in the this diagram. It looks like this only. So the more compression portion and the less tension, these kind of things you can see that. So here also this may be reflect here. More compression and less tension is there here, like kind of things we can see. So what you learn here means the variation of load with strain, the variation of load and variation of load strain at the different vertical locations of normal concrete, and the FACA grid is M20, M20, M25, 30 as individually shown in figures. The strains of each beams were measured at the 2 points on the both the top surface of the concrete at bottom steel skin also. Till the yielding of the bottom reinforcement, the strains are increased linearly. The strains of the bottom reinforcement are found plastic with the sharp increases in the causes of the normal concrete, all those things. Then varies of moment and curvature. The moment curvature of beams, moment curvature for all beams were obtained from the load strain and load deflection results. Load strain and load deflection results. This is the load strain. This is the load deflection curve and the load strain curve also. Right? So from this curve, we can obtain this relationship. The strain curvature at any load is the arithmetic sum of average compression strain and average tensile strain in the constant bending moment, constant moment zone, divided by the distance between the line of measurement of the strain. The curvature increased as the load is increased on all the beams. The moment curvature response of all beams exhibited the elastic response initially, and then nonlinear transformation from elastic to the plastic. The deflection curvature, we found that 8 del divided by L square, where del is d2 minus d1 by d2 by d3. This is the strain curvature, compressive strain plus tensile strain divided by d. D is nothing but distance between the S1 and S4. What is S1 and S4? I shown the last figure now. So this is the distance between S1 and S4. So this is the how it's known. It's this portion. It's bent like this. So this first one, it's bent like this. So each curve we have some curvatures, right? This radius, so kind of things, is right. The curvature. We developed this kind of equation. For that's a representation. Here is there. You can do deflection curvature 8 del divided by L square. That is a curvature that is at shape of this one. 8 del. This is 8 del divided by L square. Then strain curvature, the compression strain plus tensile strain divided by D. We can get the strain curvature. So the strain curvature of the different low moment we can calculate and plotted here. So this figure shows that M20 FACA, M20 conventional concrete. You can see the figure of the different combinations. So we can have that deflection curvature and as well as strain curvature. Deflection curvature and strain curvature here. Then deflection under the service load. Deflection under the service load. The ultimate load of each beam was used to determine the service load of the frame. The theoretical deflection del theoretical can be determined by using the following equations. Servicing load PS is equal to PU by 1.5. Theoretical load is the our calculation. No? This is the calculation theoretical load 23 WL cube divided by 648 EA. For example, 5B384 WL cube divided by EA is there. No? Similar kind of formula. We're using different loading conditions. That's why we can get the del theoretical is 23 WL cube divided by 648 EA. Del theoretical is the theoretical deflection at the midspan in mm. W is that load applied on the beam in kilonewton. L is the effective span of the beam between the supports in mm. E is the modulus of elastic modulus Newton mm square, and E is denoted as a flexural rigidity in mm, say Newton mm square. The value of E is obtained from the 4800 root of bar root of FCK as per IS 456 2000. The limiting deflection is span by 250 mm. So here, these are the mix ID. This is the ultimate load from the experiment. This is service load. How we can get service load? From this, PS is equal to PU divided by 1.5. I can get the service load. Theoretical deflection, I can get from this equation, 23 WL cube divided by 648 EA. I can get theoretical deflection. The experimental deflection is measured by means of using LVDT dial gauges so on. So this is the experimental deflection. Then limited deflection is given by IS 456 2000. We can measure, for example, M20 grade concrete. Theoretical deflection 5.83, then experimental deflection 4.65, and a limiting deflection 5.2. So the theoretical deflection is slightly greater than that limited deflection, but the experimental deflection it's limiting with value of 5.2, here 4.65. Similarly, the same trend you can observe all this all other specimen also, right? So likewise, we can ensure our concrete specimen is good for the limiting deflection, and also more or less is aligned with the theoretical deflection when compared to the experimental deflections, and on par about the limiting deflection suggested by IS 456 2000 also. Then another very important phenomenon, it's a stiffness. Stiffness is a highly influencing factor for the earthquake resistant structural designing systems. So how does this beam is stiffened? It's a long time. So simply we can define the stiffness by means of load required for the unit deflection of the beam. How much load is required to make it the unit deflection. Stiffness can be determined by the calculating slope of the tangent drawn to the load deflection curve. For example, this is the load deflection curve. I want to draw that curve. I can get the stiffness, and I can draw some curve here. I can draw some curve here. I can draw some tangent here. That is a different cases. That is a secant modulus, tangent modulus, instantaneous modulus. Lot of modulus is there. So leave it that. The stiffness can be determined by calculating slope of the tangent drawn on the load deflection curve. So I want to draw the tangent from this origin that touch this. What is the slope? That is called as a stiffness. So if you have the more stiffness, it's good, no? So then its building it may not be failure easily. For example, you can take the stiffness of the rock, it's very less, right, when compared to the stiffness of the steel. So immediately it will break. In case of plain concrete, the stiffness is very low. In case of RC, is a little bit okay. Then instead of fiber reinforced concrete, some more stiffness. So now the stiffness can be determined by calculating the slope of the tangent drawn the load deflection curve. That is called as a stiffness. The stiffness is found to be increasing for both normal concrete as well as the FACA grade concrete, increasing the grade of the concrete. So if you increase the grade of the concrete, stiffness also increases. This also some this trend it maybe exist some extent also. So suppose you maybe increase the grade of the concrete, the higher grade, so the brittleness will be increases. Brittleness will be increases. So brittleness increases means how it looks like this curve, load deflection curve. For example, the curve with reinforcement, it looks like this. For example, only this is not exactly a concrete curve. Then it's in case of the concrete without any reinforcement, the plain concrete, it maybe looks like this. Looks like this, otherwise it's maybe looks like this kind of things. So now I want to calculate what is the slope, what is the slope, or what is the slope, something different. It's correct, no? So something is different. It's easily brittle immediately. It takes some time. So from this also we can come to the conclusion which one is a very good stiffness. How does this aggregates is contributing the stiffness? Same kind of things we may be extended for fiber reinforced concrete also. If I can add some fiber, how it behaves and how this stiffness maybe changes and all things, we can enjoy that. You can find that. For M20 grade concrete, M20 grade of concrete, the concrete is found to be 3.5 lesser than the normal concrete. On increasing the grade of concrete, the stiffness of Aka is found to become more than normal concrete. That's why what we claiming here means the Aka somewhat influencing the stiffness also. For M25 and M30 grades, the stiffness of Aka grade is 3.2% and 17% respectively, more than the normal concrete. Conventional concrete is less when compared to the Aka grade concrete. This is a figure shows that different grade of concrete with respect to the stiffness in kilonewton per mm. For example, M30 Aka, 35, and also so on so etc. Another one things I want to discuss here. We are working in that one more area also. For example, I'll give some kind of cyclic loading to the beams, right? Cyclic loading or reverse cyclic loading kind of things. I can get the deflection as well load also. I will give that load like this kind of things, right? My load deflection curve looks like this, right? So I can draw the tangent of each cycle. Each cycle, I can get that stiffness. For example, I can calculate what is the stiffness of this curve. I can calculate. Then second cycle, what is that stiffness? Third stiffness I can calculate. Then for this curve, similarly, I can calculate the stiffness. So from this, I can calculate one more things also. You maybe know about that. That is called as failure envelope. Failure envelope. So you can see this is the curve. It's the first cycle. The second cycle. This is the first one. First cycle. This is second cycle. This one is third cycle. This one is the fourth cycle and fifth cycle. Sorry, fifth cycle. Right. So these are the cycle I can develop. I plot that load versus deflection. Then these are the stiffness in the first cycle, stiffness in the second cycle, stiffness in the third cycle, stiffness in the fourth cycle, and all those things. Now I want to plot this failure envelope. Is correct? I can get that failure envelope. I can join these points. 1, 2, 3, 4, and find all those things. So I can draw this line like this. Okay. So this is the failure envelope of that column, of that particular specimen. You can develop this kind of specimen. And one more thing you can learn from this now. So what is that stiffness degradation of this one? Now, for example, I can take this curve. The first stiffness around some unit. Second stiffness, some around unit. For example, you can compare this. You have the slope variation is correct. For this slope is different. Slope is different. So the second curve slope is something different. So slowly we can calculate the what is the stiffness of the cycle 1, cycle 2, cycle 3 up to nth cycle. I can get that stiffness degradation. Stiffness degradation. Like kind of things I can get. Stiffness degradation. For example, up to this cycle 1, cycle 2, cycle 3, cycle 4 kind of things. Right? If my stiffness degradation, it's not drastically come down like this, it's not good. Not good. Why? Because so unable to escape from the building. It's not good for the earthquake resistant structural design system. It's not advanced one. But our material, our system, it behaves like this. For in case of ideal means, this is x-axis, y-axis, stiffness degradation. It's like this, then like this, then like this, then like this. Like this means good because we have one warning here, another warning, another warning. Then it's good. So these are the some stiffness degradation. So now we can take this part. So why this the slope is very fast is managed, is right? Very deep slope is correct now. So why it's happening? So what are the materials contribute? What are the shape or what are the other contributions to stiffness degradation in the drastic level? So after this second cycle, for example, only this is stiffness degradation something different. After this slope, you can calculate the slope of this line, no? Something is a different when compared to other two pieces also. So up from this portion to this portion is very good for the as for the structural engineers. So the sudden drop off that the stiffness is not good for civil engineers. So we have a lot of research is going on how to make this the structure like a gentle stiffness kind of thing for the gentle stiffness, for example, like this. This is good. Then like this. So how we can make this? Lot of research is going on. For this purpose, we can add some fibers. We can change this material and the shape of the specimen, right? And increasing or decreasing grade of the concrete under the solution to reduce the stiffness degradation or drastical stiffness degradation mechanism. So you maybe take the course in that of advanced mechanics. You can enjoy these kind of things. So what are the forces acting? So how this, why this stiffness is degrade and all those things we can learn. Otherwise, we may be ready to work the cyclics and reverse cyclic loading. These kind of things we maybe learn. And also, in case of vertex analysis, we can get this kind of information. So what is the failure envelope? So on those things we can learn. So in this figure, how to calculate the stiffness, how that stiffness is contributing, how this stiffness relating, or how this stiffness is depending upon that metal property we seen here. So what we claiming here means the Hong is slightly contributing the stiffness also. That's why claiming here. Yeah. Another very interesting topic is energy absorption capacity and energy index. So what is energy absorption capacity? So previously we seen that ductility, right? Ductility is the deflection phenomenon, right? What is it? Deflection, yield and ultimate, right? That is a ductility factor. But here, energy absorption capacity, how much energy this material is stored in terms of strain energy, in case of flexural strain energy, tensile strain energy, compressive strain energy, so on so strain energy. Here also, we can calculate the energy absorption capacity or energy index. How we can calculate the energy absorption capacity? One of the major parameters that define the seismic behavior is the energy absorption capacity of the structure. When the load is applied to the structure, remember, some energy will absorbed by the structure itself. Structure itself up to the certain limit. What is the limit? We will see. This capacity of the structure is usually termed as the energy absorption capacity. Right? When a load is applied to the structure, some energy will be absorbed by the structure itself up to a certain limit. This capacity of the structure is usually termed as energy absorption capacity. The energy absorption capacity of reinforced concrete beam is the area under the load deflection curve. Energy absorption capacity is nothing but the area under the load curve. This area under the load deflection curve is represented as energy absorption capacity. So you have asked some doubt, no? So up to which limit I can take? Up to the PU, you can take this kind of things. For in case of plain concrete and all, this curve it's maybe like this one, like this. So you can get very less amount of energy absorption capacity. This is one type of method you can find that energy absorption capacity. So we observed energy absorption capacity up to the ultimate loading. It's a kilonewton meter. Then different grade of concrete is given M20, M20 FACA, 25, 25 FACA, M30 and M30 FACA is given. This is energy absorption capacity at that things now. Then energy absorption capacity up to the yield loading. This is the up to that ultimate. That is a yield loading. I can calculate it here. Then energy index also I can calculate. What is that? Energy between these two is can calculate. That is called as energy index. Energy index. For example, how we can calculate energy index? Energy index, that is that energy absorbed up to that ultimate loading. Energy index up to that ultimate loading. Up to this, what is the energy? Then energy absorbed by the yield loading. Yield loading. Yield is maybe here somewhere. So up to this I can cut. This area I can take A1. This area I can take A2, for example only. A1. This is A2. Energy index is nothing but energy absorption ultimate up to this A1, that is called as up to that ultimate. Then A2 is nothing but up to the yield. What is the ratio between this is called as energy index. So here also we can calculate cumulative energy absorption capacity. Cumulative energy absorption capacity. So what is the cumulative energy absorption capacity? So if I can take any kind of specimen is subjected to cyclic loading, for example. Previous only I explained now. For example, cyclic loading and given load is that ultimate where it is. I can draw the tangent of this line is correct. So up to this yield, then this is the ultimate. So here I want to take what is that energy absorption capacity in case of ultimate and yield also. So reverse cyclic loading. Then I can add what is it E1 energy 1 in this specimen E1. Then I can take this is E2. I can take E3, E4. Summation of E from 1 to infinite. You can get that energy absorption capacity Newton mm or kilonewton mm kind of things. So this is called as a cumulative energy absorption capacity. Cumulative energy absorption capacity. And otherwise I can give this cyclic and reverse cyclic loading. Cyclic and reverse cyclic loading. I can get that curve looks like this. So how it means? So suppose you may be working the beam column joint, we can enjoy this kind of curves kind of things, right? This kind of curve we can get. Different type of loading will be changes. I'm drawing the an approximate curve also, ideal curve. I can see, no? So from this I can find that what is the area of this area, this zone and this zone and all I can calculate. So finally I get that what is the energy absorption capacity kind of things. Another one is crack behavior and crack pattern. Most of the people do this analysis. You should observe the first crack when it was happened. Then you can plot also is the crack. For example, how you can mark the crack in that experimentally. I can explain here. Yeah, I explain here. For example, I can take one beam kind of things here, correct? Then this is the beam. I can make one grid. For example, well-defined grid kind of things. Otherwise, I paste some graph sheets in above that specimens, this kind of things. I can make it from grid. For example, 1 centimeter by 1 centimeter or 2 centimeter by 2 centimeter square, we can make it possible, right? So I can make like this. Some in researchers, this may be useful. Then this is the support, is right. This is the support. So we know what is the size of the grid. For example, I can say the size of the grid is by 10 mm by 10 mm or 100 mm by 100 mm. For example, 100 mm very less, 10 by 10 mm. I'll make the grid. Okay. So if we here no, this is square is 100 mm by 100 mm. Say 10 mm by 10 mm. Similarly, this is 20 mm, 30 mm, 40 mm kind of things. Otherwise, according to your convenient, usually what we did now, 1 inch by 1 inch we do it. 1 inch by 1 inch we'll do, right? I can apply the load. What will happen? It tends to bend. Sometimes I can get that crack. You can apply in this field also, right? Apply the load, then crack maybe starts. The first crack it maybe starts like this. So like this. So that time now you have the LVDT and you have that load cell also. From this you can measure or preliminary what is the load. For example, the first crack it starts, load is 15 kN. Then you can write here up to put one cut mark that the crack, cut the mark, the crack, you can write 15 kN. I can apply the load 20 kN. 20 kN. This crack may be extended here. Extended here like this. So now put one cut kind of things. You can write you can write 20 here, 20 kN load. Otherwise, this may be 50, 60, 70 kind of things. It's maybe propagate. And after sometimes now this is 20, maybe 30, another one is a 40 kind of things. Then the 20 or 20, for example, some places now 20 kilonewton crack will start. Crack 20. After this is the 30 kind of things. So multiple crack will be starts kind of things. So from this, we can plot all those things. So we know that where it is a crack. In case of length of the crack also we can find. For example, I want to find what is the length of the crack. Is you can see here now. I can take this alone. This figure alone. I can measure what is the size of the grid. Size of the grid. So 1 inch by 1 inch or 10 mm by 10 mm. Then this grid looks like this now. Then you know what is that 1 inch. The height also 1 inch. So we can get the square or 2 root of 1 inch root of 2. You can get this length of right now. Similarly, you can add all the grid now. So this grid you can add, this grid you can length of the crack also possibility you can find. Or else you can use that crack detection method. Crack micrometer is there. You can use that. You can find what is the width of the crack also possibilities there. So likewise, we measured that. So we measured the first crack was developed in that constant bending moment 0. All the cracks in the members found at the flexural zone, except few. It can be seen that all the cracks were propagated from the bottom towards the top of the beam. Number of cracks found at the yield point of the concrete is less than the normal concrete at every particular grade of the concrete. The concrete members were more brittle than the normal concrete members. The cracks are in the flexural zone, except for the few. Some of the cracks are propagated from bottom towards the top of the beam. So these are the some observation we did, and we found the number of crack also. So 5 kilonewton, how many cracks I can get, right? In that number of cracks. In case of 30 kilonewton, how many cracks and where it is. These are the things we can learn from this kind of graphs. So these are the crack spacing. What is that spacing of the crack also I can measure, right? Then crack propagation in mm. How do you calculate the length of the crack using this sheet analysis, right? Then crack width using the microscope, I can find that what is the width of the crack. So a lot of information you can learn from this kind of study. So this is very useful if you find that crack width theories available in the IS 456 2000 in the annexure. We can compare the theoretical calculation and experimental crack width and the crack depth and all within the limit and all we can check it. So now you can prove your material or structures is maybe structurally strong and is good when compared to the conventional material or conventional structural system. You can claim and compare with your IS code also. So that is the uses of this study. Now the failure of crack pattern. It is interesting crack pattern observed here. Here you can see M20 concrete. They have the less number of cracks compared to that M30 facas, right? You can see this now, no? M30 faca. We can see the number of crack is more, it's correct. We measured, no? What is the load here? You see. Okay. So number of cracks also is more in case of M30. Then, for example, first I want to compare M20 and M20 faca. M20 and M20 faca. The same specimen. The specimen is different, but the same length. That's a scanning of the specimen is same length. You can see the pattern. Is here something is there, then something pattern something different here. Then here the length is also different. The propagation of that crack also is different. So what we observed here means we can count the number of cracks in the M20 is less than compared to that M20 faca. And you can measure the width of the crack also and the depth of the cracks, how much is inside. This also we can take in account. So this kind of study is very useful for the other studies. Then M25 and M25 faca, we observed one more failure here. The M25, the horizontally it fails, then it looks like this. So mostly we can calling that is the bending shear. Bending is there, the shear also is there. We can climb. So because of that, this may be number of cracks may be reduced. Instead of that, we can get the crack, the horizontal. We want to recheck it and all those things. Recheck it and all those things. So here also M25 faca, it's how that the behavior is something different when compared to that M25 conventional concrete. You can see that number of cracks and the depth of the crack and length of the cracks, so and so. And M30 and M35 faca, then M30s have that huge number of cracks, but M30 faca, it's a less number of cracks when compared to M30. So this is, I think, good when compared to this very less number of cracks. And the length of the cracks is not up to the mark. The aggregate is not worked well when compared to the M20, M30 faca. Right? You can see that figure also. So likewise, you can write a lot of observations from the specimens. So what is that contributions and why it becomes like kind of things. For example, I want to reduce that more number of multiple cracks. I can add some fiber. I want to reduce that opening of cracks. Reduce that or confine the width of the crack. I can add some steel kind of fibers. The micro cracks and all I can arrest by means of small fibers like a microfiber macro fiber, so on, so like that. So these kind of things is learned from this study. And come to the conclusion. Yeah, the dry loose density of FACA was less than 1,100 kg per m cube. Hence, there is aggregates can be classified as the lightweight aggregate as per IS 91421979. We can call this is a FACA as the lightweight aggregate. Why? Because the density is 100 kg per m cube. Even you can increase that molarity of that FACA, you can get that greater dry density of the concrete. Yesterday, after that presentation, Sandhugam sir asked the doubt. So this aggregate, it may be commercialized is possible or not. The possibility is there. Why? Because possibility is there for the commercial viability. What is the problem at present means we can produce aggregate densities around 1,100. We want to increase around 2,000 kind of things. We increase that molarity. If we increase the molarity, the cost is maybe increases. So this little bit costly when compared to the conventional concrete. It's a conventional aggregate. And he asked about that some machinery is there. Yeah, I applied the pattern also for that artificial concrete coarse aggregate making machine. The working principle I will tell you, that's not an issue for me. Already I published that patent. For example, I have the two kind of dies. For example, this I have one cylinder. One more cylinder is there. One more cylinder is there. This cylinder have some projection. These cylinders have some kind of projection, not a projection, it is engraved in the surface of the cylinder. Surface of the cylinder. Otherwise, you can see this in the elevation. These cylinders surface looks like this irregular shape kind of these things without any gap. That is again you do for optimization and all. You can get that lot of options. So this is cylinder. It looks like similarly it's the same kind of projection is there in that opposite direction of the cylinder. These two cylinders rotate like this. Then we can feed the raw material through this or some arrangements. Right? Some arrangements we can feed this. Right? Okay. So the material is going inside. These two joinings together, you can get irregular shape aggregate. Then it's falling down. You can collect the tray or it may be conveyor belt. You can store somewhere. You can use this kind of material is a possibilities there. So this is the patterned one. So we applied the pattern also. The possibility is there to manufacture the aggregate in industrial scale also. Suppose you need some regular aggregate, we have another technologies also. So previously we did the same kind of pattern. What I did now, one cylinder is there. In cylinder, we have some kind of projections. Small projection is there, kind of things. This also looks like kind of blade kind of things. Here also, it looks this kind of. Okay, this material is falling this direction. It tends to rotate clockwise or it is anti-clockwise or it is a clockwise. Then it's rotate now. So you can get the irregular surface aggregate. We can collect or transferring to the conveyor belt. So this way we can take that fly ash artificial coarse aggregate. And some people doing that work, suppose you take in that concrete mixer machine, 3 arms is there inside. You remove 1 arms and you can tilt that concrete mixer machine around from 20 to 35 degree, different degree variation is there. Then you can change the angle of the drum from 20 to 35 degree. Then remove 1 arm inside. Then put these things, we can get the aggregate, irregular shape aggregate. What is the problem in that means? We are unable to get that very sharp edge. For example, we can impact that no aggregate that's easily break. That's why we are not up to the mark. For that's why we are invent these kind of methods. This here the pressing also is happening. No, this portion we can get the pressing operations. That's why we can get the very good and irregular shape kind of aggregate we can get. So what are the die you provide here means we can do it. So what we did means I can change this die in case of this irregular shape. Suppose I need the 12 mm downside aggregate, downside aggregate, I can do it. I can change this. Suppose I want to need only the 20 mm aggregate, I can do it. So that kind of facility is a pattern it. That is things I want to share here. Then the FACA aggregates, I think I scope answer your question, sir. Yesterday he asked Professor Sandham, sir. I answered this question. The FACA aggregates are not suitable for the concrete. We subject to the freezing and thawing due to the high porous nature. That is another drawback. We want to rectify it. This is taken the challenge and the opportunity to for upcoming engineers, the researchers. So these are the some problem, freezing and thawing problem. Now, what is the added advantages for this? You maybe take this maybe lead in this other aspects. So this artificial aggregate, it's maybe inside this have some porous in nature. Why not this may be used for that filtration purpose? That you can try. Any other environmental friends is there, you can try. And why not you maybe use this absorbent for the treatment plant and all those things. You can use. You can try because it's a very porous in nature and it's maybe like some mineral kind of things. No, you can easily recharge it. So you go for that back. 1 second. Hello. Yeah. Any agent? Please tell me first. Put message. Right. Yeah, sorry for inconvenience. So the porous in nature, that is maybe due to this porous nature, we can use this kind of material for the effluent treatment purpose, so and so like that. Then the impact value of ACA is less. Yeah, when I showed that 15 to 45%, it should be improved. So that's why we are developed this kind of machine. So slightly we can rectify that kind of problem. Impact is maybe getting down from 10 to 15%. There is also possibilities there. Then FACA shows the high resistance for the crushing. Then abrasion value of FACA is 35 to 60%, less than the conventional coarse aggregate. Is try to improve this kind of things. The FACA aggregates prepared can be used for the wearing of well as non-wearing surfaces as per IS 383-2016. On examining the FACA using the same images, it is noted that these aggregates are porous. However, unlike the sintered fly ash aggregates, the porous in FACA is not continuous on means we have some advantages also, is correct. So you may be aware about that in case concrete cross section. Then these are the some kind of pore kind of things. So these are the some also different materials inside is assume only. Right? Suppose we can take this in case of durability issues. No, durability is the pores is continuous. We can get one path. So this is the all solid it goes. So here discontinuity will happen. Right. So I can take from here, they have the continuity. So the water is maybe going this direction. They have some break, then continuity is there. So path 1, P1, P2, P3 are all highly contributing the durability properties of the concrete. So what we are claiming here, this path is not continuous. They have some advantages, the durability aspects of the concrete that we concluded here. Right. So the continuous and not continuous path. That is. So again, you go in deep, you can get some lot of ideas. What is a gel? What kind of gel was formed? So what is that bonding between that and all? Another level of research. Then mix of M8MA1, useless amount of NaOH, hence it is most economical mix. Use less amount of NaOH, it is economical mix. Again, we have the question mark regarding the strength aspects under that other mechanical property related to the material. Then slump was kept below that 100 mm. Since normal weight concrete comes within the range of 2200 kg per m cube to 2600 kg per m cube, concrete can be characterized under the lightweight concrete section. For example, you can use for in case of lightweight roofing or in case of filler material, that all you can use this kind of concrete. The compressive strength of the concrete is comparable with that of a normal concrete. The split tensile strength of the concrete obtained experimentally was higher than the values obtained from IS codes and all those things. These are the some observations. Then concrete is more suitable for higher grade of concrete also. We proved that the concrete can be recommended for that acidic environment. Acidic environment, the faca has to more resistance to acids than the crushed blue stone aggregate. This we need to study in the long run, how it works and all. We can examine it. Then, with respect to the structural behavior, at the initial stage of the loading, the concrete shows the increase in the deflection rate when compared to that normal concrete because of low modulus of elasticity, which influence the concrete cracks controlling the capacity. Then concrete is sometimes recommended for the higher grade also. The partial replacement of the coarser grade reinforced concretes can be studied. The structural behavior and these are the some limitations of faca. The partial replacement of coarser grade faca reinforced concrete can be studied. The structural behavior of faca under the cyclic loading can be studied. That is the possibilities there, is right? Under cyclic loading, how it performs, like cyclic loading, reverse cyclic loading, that kind of things, how it's performed. Behavior of faca grit in the beam column joints is to be studied. Suppose we proved this material is little bit good for that earthquake resistance kind of things. Suppose we can take the beam column joint like this. This I can take. This is the column. This is the beam. Beam kind of things. It's not figure. It's not good. This is the column. I can fix here. I can apply the load. The beam column joint in that forward direction as well as backward direction also with respect to the increment of load. It looks like this. Then what is the behavior of the beam column joint? So we proved the energy absorption capacity. For example, you can see this figure now. Yeah, you see this figure. The energy absorption capacity is more. Here also he proved this, right? Energy impact factor is more for that M30 grade of concrete, right? So you can implement this kind of aggregate, in particular beam column joint, in particular the region, this region alone, how it behaves, we can check it. And also we conducted one study also, how this position of plastic hinges is maybe changes with respect to the different types of material also we discussed. So we studied and published one paper also. Then behavior of concrete beam column joint we maybe study. Then life cycle assessment of, this is another area, life cycle assessment of the newly prepared coarse aggregate faca can be studied and compared. The analytical study on the structural behavior of the concrete can be studied and compared with the conventional concrete. The study on the largest production of faca should be implemented in the future. So you maybe think how we can produce the huge quantity of faca with the quality control and all. So here I'm not talking much about that, the curing of that faca material. So mostly nowadays, no one is going for the steam curing in that the beginning stage, the David Ovis, that time and all, he is highly worried about the curing of that geopolymer concrete. But now almost they'll stopping the curing just to put in the ambient temperature. Otherwise, you can add some chemical admixtures. It automatically tends to cure. That is another added advantages for that. So we have some other disadvantages also. So it's maybe alkaline nature. So you maybe think about when it's this chain of reactions will be break. That kind of things you should be addressed. Right? So we are claiming the aggregate strength is getting due to that uh, polymerization process. So how this polymerization process is happening, when it will be ended, or else I want to break after some time. How I want to break it. So these kind of things we want to study more and concentrate. We want to study about what is the chemistry of geopolymer kind of makes. We can get a lot of informations. So these are the some today's presentations about the advanced technologies for the reduce the damages of the structures. Then in addition that, so we replace only the coarse aggregate here. So instead of coarse aggregate, we can replace the fine aggregate. We can add some fiber also, like a steel fiber, glass fiber, basalt fiber. Then armed fiber, then textile fiber. So also that also improves some structural property. How this kind of material improves the structural property? We can take one more study that is also good. In addition that, we can take some advanced machine learning techniques also. So prediction of the joint, these kind of things. How we can predict these things means from the past experience, we have that some data. For example, how I can predict now. Today rain come or not? How we can tell? So we have the some past data of the rainfalls. Then from that we can come to the conclusion. Today rainfall it maybe happen kind of things. So how means we have that enough number of data. We can compare this previous data, then predict the new. Similarly, here also some people did some researches in that researches the replacement of coarse aggregate by means of FACA and all those things, other aggregates. You take the data and you propose the new model. Your model should be reflect the what is the ultimate compressive strength, tensile strength, and other properties of the material. Like this, we can explore these things in the machine learning concept also is possibilities there. So these are the other area of research you may be focus. So we have some experience in that these similar kind of areas. We replaced the cement by means by silica fib GGBS also. We did some study. Then adding the fiber inside the concrete mixes, we did some study. That is where that is we called as a basaltcrete. One of my students did in this area. Basaltcrete. Add the basalt fiber, what will happen? And one more student is did that steel fiber. Then one students did the work in that combination of 2 or 3 fiber. That is a hybrid fiber, how its behavior. This kind of things we did. So likewise, we did a lot of what we have experienced, a little bit experience. What is the behavior of structural element subject to the cyclic and reverse cyclic loading? And if you change this metal property, how it's helpful for the structural aspects. These are the things we did. So refer our paper, you can get a lot of idea. See, in addition that, I want to share some research experience also. If you add some kind of mineral admixtures like a nano level, the nano silica is there. We can add means you can get a very good compressive strength also. I cannot exactly tell how much is maybe increase the compressive strength. Some significant improvements will be happen. So I give the tips too for all researchers how we can means. So most of them will doing the research in the concrete. You cast the more number of specimen. It's not good also. You are indirectly polluting your globe. So instead of that, you find some concepts, you find some mechanisms, right? For example, you read some paper. They wrote the compressive strength is increased 60% to 80%. That is one clue for you, right? So you go in deep. So why the compressive strength increases, right? So which are the contributing factors? What are the factor contributed chemically? What are the factor contributed physically? Then what are the factors contributed physiochemically? Then what are the factors contributing to biologically? Then once you know the concepts, so what are that influence inside these things? Then quantify using the mathematics. Quantify using the mathematics. So what you keep it in mind, the basic science is a very, very important for any kind of researchers. You maybe answer these kind of things in terms of science. For in case of physics, chemistry, biology, mathematics, you can get the very good paper also. So nowadays we are looking at mechanisms. So what are the mechanisms inside? How its strength is gained, or how its strength is getting down, how the properties maybe of material maybe increases or decreases. This kind of things is learned from through that mechanisms. And a very good journal paper, they're expecting this kind of things only. So if while writing the paper, you should be keep it in your mind. It's very useful for easy publication also. So likewise, you want to improve that work research skill also. I hope I want to conclude my talk now. So I maybe this topic is slightly fulfill your theme of your ATAL FTB program. So here demonstrate some technologies to how to reduce the damages during the earthquake in the research point of view. I explained. The practical it's maybe slightly different. I'm not talking about any kind of systems to design that earthquake kind of things. So that is a limitation of our study. So I thank you very much once again. The organizer is giving opportunity here to share some idea regarding is my area of research. And thanks, my acknowledgements and sincere thanks to my research scholars, BTech and MTech students working under me, maybe supported me in such directly, indirectly. Thank you, Ananda. So this is the right times to discuss something. Another so time exactly 7:15. So another 5 to 10 minutes we discuss. If you have any queries or any things you want to discuss means, if it within my domain, I will answer that question. So or to organizer, you can ask anything means we can discuss. Thank you. Dear friends, any kind of queries or any kind of discussion you need means we can discuss with you. Organizer, please unmute mic to all. Organizer.
Sir, we are unmuting, sir.
Yes, yes. Any queries means we can discuss. Suppose you have any queries, put in the chat box. I can see the chat box. So any discussion regarding this presentation? Okay, I hope this maybe is understand it well. I kind of things I can think in positive sense. So any improvements means we can put in that feedback. I asked that organizer to send that feedback to my mail. I will improve my presentation as well as the technical content skill also. Thank you very much. This is very good opportunity. Share my some ideas. It's my own alumni institutions. So I'm very happy to all and my best wishes to all also. I convey my regards to principal, dean directors, management, and other faculty members in the DSPC. Thank you very much.
Thank you, sir.
Thank you, madam. Okay, can I leave now?
Yes, sir. You can leave now, sir.
Okay, thank you very much, and all presently sitting here. Thank you very much.
Participants, kindly fill the feedback form for this session, and the program will be start very shortly. Followed by second session will be handled by Dr. G.S. Ram Pradeep sir, is working as an associate professor in the Department of Civil Engineering at Kongu Engineering College, Erode, Tamil Nadu. He has completed his graduation in civil engineering from Kongu Engineering College in the year of April to 2008 and completed his master's in structural engineering from Banariaman Institute of Technology on May 2010. He was awarded with 2 gold medals for his outstanding performance in structural engineering from Banariaman Institute of Technology. He did his doctorate in the field of intent curing concrete from Anna University, Chennai, and completed successfully in the year of May 2017. He is working in Kongu Engineering College for past 11 years and has published more than 25 papers in reputed conference and seven papers in the reputed international journals. Presently, he is one of the youngest director in the Indian chapter of American Concrete Institute, Mumbai. He is the recipient of various awards, includes Tamil Nadu State Council for Science and Technology, Young Scientist Fellowship, undergone a short-term research for publication in fellowship in concrete 3D printings at IIT Hyderabad, Best Poster Award in the International Conference conducted by Anna University, Chennai, All India IEI Engineering Award at Delhi State Center, New Delhi, American Concrete Institute Project Completed Award from ACI USA, American Concrete Institute Collaborated Award from the IoT-based RC Concrete Motor Race from the Zhejiang University, China, National Concrete Canoe Championship under ASCE SRM Student Chapter, ACI International Travel Stipend, ACI Chapter Activity Award, Best Mentor Award, Best Paper Award, IE Young Engineer Award, Dr. APJ Abdul Kalam Durban Inventor Award, IEEE Consumer Society Award, etc. from the government agencies and reputed organization. He has completed successfully awards and completed a research and seminar grant over a lakh from various agencies like ACA, CSIR, etc. Recently, his projects was sponsored with an amount of 5 lakhs from ACA Innovator Scheme, New Delhi. His another team was sponsored with an amount of 6.7 lakhs from IIT Madras. The invention made from a carbon zero challenge scheme is published in India's leading articles like Times of India, the New Indian Express, 11 brilliant invention in the world. He has awarded 2 design patents for the design of carbon dioxide curing chamber and the canoe under a government of India. He is holding 3 copyrights and his inventions is awarded in a TOYCAN 2021 and made in an Indian scheme launched by an Honorable Prime Minister of Narendra Modi. We are very happy to welcome you for this session, sir.
Thank you, ma'am. So, am I audible, ma'am?
Yes, sir. Audible, sir.
Yes, sir.
Yeah, warm good evening to one and all gathered here for the ATAL FDP program in the area of disaster management. So, thank you for the coordinators for the warm welcome. Today, we are going to see the main important topic which is the interdisciplinary aspect combining the civil engineering in tie up with the most advanced current technology field, what we are what we are discussing now in the recent days. So without this, I think the world will not sustain, right? People, we are mostly talking about the artificial intelligence, which combines the IoT, the advanced technology, which we can operate or which we can monitor from the remote distance where we are. So the concept which originates uh, to minimize the cost incurring during the project, or to monitor, or to gather multiple aspects, right? So without investing more money, how we can easily solve the problem. So that is the main thing, the project related to. So today the topic is the artificial intelligence exclusively for the disaster management. So the disaster, in the sense, it is the unpredictable thing, how we can solve it out. So in the earlier days, if we see that, we will directly go to the site after the disaster, and how we are protecting the people, and how we are securing the people, and how we are providing them the next opportunity or the next place to for the living, right? So we will see in detail about what is the disaster management and what are the tools that we can apply to monitor, and how we can use the artificial intelligence in detail about the same, right? So with this, I will move to the next slide. Next slide, please, ma'am. So here, the AI applications in disaster management, right? So this is a very beautiful area. So why I'm telling this is, currently, if you people are more interested to do the short-term fellowship, or the very youngest faculty, those who joined in this program, so there is an opportunity in the central government reputed institutions like IIT. So coming within very few days, they will going to launch the summer research fellowship, right? So in civil engineering also, we are having the multidisciplinary concept called augmented reality or virtual reality, right? So if you people are more willing to apply for summer research fellowship, I think this is the very right time to get interdisciplinary aspects like artificial intelligence, IoT, artificial intelligence, machine learning, deep learning technique, etc. So here we are focusing mainly on the disaster management. So the disaster management can be the flood, or the disaster management can be the seismic studies, the earthquake, right? So the application of artificial intelligence not only involving to the disaster management, also to the construction industry, like how to predict the workmanship by the workers they are involving in the constructions, right? So starting from the attendance monitoring, starting from how much work they have completed in a day, how much brick volume they have laid, how much concrete they have made, and what including with nowadays the L&T, they are more focusing on the artificial intelligence, like how to monitor or how to predict the lifetime of the workers. Whether the worker, for example, if he is coming to work in the work for the day, whether he is a normal person or he is a stressed person, what is his stress level currently, everything we can able to predict through the artificial intelligence. So the artificial intelligence, the topic is very, very essential for the civil engineering domain in current days exclusively for the mitigation studies as well as for the workers' safety aspects, right? So those people, if you are going to start your PhDs, it's a very foundation area problem gap and a research gap analysis area in the artificial intelligence, right? So here we are going to see covering the 4 important topics under the disaster management connecting with the AI. First one is the mitigation. In the mitigation, we are going to see the predictive modeling, how to make the prediction analysis. So for example, in earlier days, hope everyone will know that. If you are not aware of that, please listen to my words. Actually, in the previous days and all, the project involves only we are going to the laboratory, taking the material, testing the material, producing the results, and making the book. That's it. Only we were mainly depends upon the instrument, right? We are casting the specimen, we are keeping under the machine, we are giving the load, the output what it is coming, that is the final thing we are producing in the book. We will not know whether the result obtained is correct or not, right? Second thing, see, in the competitive world, we need to complete the task well in advance. For that, the prediction aspect is most important, right? Prediction tool or prediction modeling is so important. In alternate words, we can able to tell it is a simulation, right? Starting from identification of materials, choosing the properties of materials, analyzing its behavior, all the things, everything with respect to the environmental sector, right? So we cannot fix the environment, because predictive modeling, the very important parameter is the environment, atmospheric condition, right? As a civil engineer, we need to know that, for example, if we are constructing a building in zone 2, right, there is no problem. Zone 1, zone 2, zone 3 and all, there is no problem. Hope you people know that in IS 1893, earlier it was classified into zone 1, 2, 3, 4 and 5. But in the latter days, zone 1 and 2, it is clubbed as zone 2, and zone 3, 4 and 5 are the respective zones. If it is in zone 2, there is no problem. If it is in zone 5, the disaster will be very higher, right? So we come to know that the presence of weaker plates will be there below the ground level. The tectonic plates will be very weaker. So the triggering of the focus point of earthquake will be very higher, right? So here, what I'm going to project here is how we can predict it. Well, I don't know whether you have gone through the technology called past history analysis. So if you are well versed, or if you are very most interested in earthquake engineering, right? So the northern part of India, like IIT Roorkee, IIT Kanpur, they are doing very advanced activities, how to design the building to resist from earthquake or seismic activities, right? So here, the technology is called past history analysis. We need to consider the past earthquakes, when it was happened, what is their magnitude, what is the intensity scale, Richter magnitude and all. So based on that, the building will be designed, right? So here, in the modern technology of the world, in the competitive technology of the world, we need to coin the term called prediction, right? We need to predict the behavior of the structure, what we are going to construct in advance. Based on that, we need to choose the materials, we need to choose the technology, we need to choose the methodology, like that, right? We need to make the risk assessment, what are the possible risk it will come, right? So that we are going to see in detail in the coming slides. And second thing, preparedness, right? So how we have to get ready to face the issue, right? So in that we are going to see the early warning systems and resource allocation, right? And third thing, we are going to see the response. Every behavior, there will be a response. Say, for example, you are choosing one material, let it be the steel, right? There is an important concept called ductility, right? So in IS 13920, exclusively for ductile detailing of structures subjected to earthquake, right? So it's clearly explained how the energy absorption should be for the steel, how the energy absorption should be for the material what we are going to design subjected to earthquake conditions, right? So if we are giving a lateral load, there will be a response for that lateral load, right? It is a cyclic loading, right? It is a dynamic behavior where the load will be changed, keep on change with respect to the time period, right? So for every material what we are using, there will be a this appropriate responses for that material, right? So based on that, we can able to make the damage assessment, and we can able to make the situational awareness, right? What is meant by situation awareness means the material what we are using for one structure will not be usable for the other structure. I will tell you the example. See, actually, the lightweight material, say for example, a very lighter density, less than 800 kg per meter cube, right? So what the general code is telling, if we are using for PCC, right, the density will be of 2400, 2200 to 2400 kg per meter cube. So when we are using the steel in a hybrid mode, the density will be around 2500 or 25 kilonewton per meter cube. But my condition in the zone 2, if I am constructing the structure, right? So if I am constructing the structure in the zone 2, if I am using the partition wall where the load is not coming, it is completely a framed structure, right? The load is distributing through the beam and column. Intermediate partition wall, I am using the Renacon block or lightweight block. Obviously, the density will be less than 1000 kg per meter cube, right? So if I am using that lightweight block in the earthquake prone area, it is not advisable because we know that the density is very less. The specimen will not able to take care of the lateral load. So for that condition, the people will go for the shear wall technology. Both main rod and distribution rod will be the used in the RCC wall, right? So what I'm going to tell is, based on the situation, we need to coin the different types of materials or different type of technology for that, right? And in the response sector, the communication and coordination is most important. I will tell you one situation, right? So it is exclusively very important in the precast constructions, communication and coordination. Assume that you are going to make the underground construction for lift, right? So you will have the crane which is standing at the ground level, and assume that there is the we are digging the ground level up to 3 meter or 4 meter. If we want to erect the lift wall, shear wall, side walls, so we need to make proper communication to the crane operator where we have to place the wall in the appropriate place. So if the coordination and communication is very lagging, then we need to make the packing rod or baker rod in order to fill the gap between the disturbances, right? So finally, we are going to see the recovery, right, which covers the needs assessment, infrastructure restoration, which is nothing but we are studying the subjects called repair and rehabilitation, right? So in this, we are studying what are the crack arresting techniques, like depend upon the size of crack we are studying, right? Whether we need to insert the prop or doesn't need, like that. So infrastructure restoration is a very important topic after the damage, right? How we are bringing back the building to the original position, right? So and finally, we are going to see the long-term recovery. So in order to sustain for long term, what are the thing we need to focus much more, right? So these are the topics we are going to cover in the disaster management in relation with the artificial intelligence technique. Next slide, please. Next slide, please, ma'am. Am I audible, ma'am?
Yes, sir, audible.
Okay, okay. Ma'am, I can't able to see the next slide. Okay, clear. Okay, so now this is the overall picture that I have projected in front of you. That is applications, overall applications relating AI in the disaster management. Starting from left to right, it's like concept map. So I will give you useful tips for you people. Recently, we have completed the course called Design Thinking and Innovation by IDC School at IIT Bombay, right? Which is an NPTEL course by Swayam. So you people now in January 2025, it is again reopened for design thinking and innovation for educators. I'm advising you people to join because they are covering these aspects, how we can implement the multidisciplinary aspects in the one tool. So they are telling this as a storyboard or storyboard writing or concept map, right? So starting from the left and to the right, what are the things it is involving? For example, nowadays, the 4 to 5 factors it is involving, as I discussed in the earlier slide, starting from mitigation, next thing is to preparedness, and to the response, and to the finally the recovery, right? The first advanced tool, you please note it down if you want. The first advanced tool where the Google has been created, that is called Flood Hub. This is one of the AI tool. It is the open access tool where they have developed the technology to predict the flood, or they have created a cloud, and they have installed or they have developed the coding. So based on that, they have forecasted the cloud for 80 countries, right? So it is an open software where you can able to go through that, and you can able to know that where the floods will be, and in future where the floods will come from. And these and all the best AI tool which was developed by the Google, it is called Google's Flood Hub, right? So based on that, it is a predictive modeling tool. In structural engineering and environmental engineering and all, we can able to tell that it is a simulation modeling, right? What is called simulation or what is called modeling? So this is very, very important sector, because why I'm telling now, in structural engineering or in the concrete and all, what we are going to study, it is called Avizo. There is a software called Avizo, AVIZO, Avizo software, which is the US based or Germany based software, where you can predict or where you can see the transportation properties of the materials. We are simply telling that if I am pouring the water from the top, the water will come to the bottom through the concept called permeation. We are studying literally, right? But we are not seeing we are seeing practically. In the lab, what we are doing, there is a water permeability mold will be there. We will place the 150 mm size cube. We have already studied two types of permeability, constant head and variable head. If we are pouring the water to the top, it will come to the bottom. We will measure it in the measuring jar. How much water gets collected, based on that, we will come to know that there is a pores or not, right? So these and all, it is an experimentation. But how you will predict, right? If you are not predicting, right, you will lose the material or you will lose the amount unnecessarily, right? Say, for example, if you want to complete the task, you need to predict it, how much labor you need to have. For example, say the best example is 3D printing, right? 3D printing, the labor content is very, very less. The robot will itself will cast the concrete and it will like precast, right? So it will cast the concrete, it will create a building. But if we are using 5 to 10 labors over there, it is waste of money. So we need to predict in advance by modeling or mathematical simulation what is the situation, depend upon the situation where you are constructing the building or where your application will be. So here the application is mainly focused on controlling the disaster or how you will manage the disaster, right? So that's and all comes under the mitigation aspects. Then it will go to the, after mitigation, it is moving to the risk assessment. See, the risk assessment not only plays a vital role in the disaster, as I already pointed, every constructional sector, this risk assessment plays the vital role. I will give you one example. If you are constructing the G plus 5-story or 6-story commercial complex, right? Assume that a worker is working in the 3rd floor or 4th floor, right? Whether he's doing a plastering or whitewashing, some other, whatever it may be, right? So every time the supervisor, it is not able to go up and down to check whether the workers are doing or what is their condition will be, right? So the international code, what they are telling now, so we need to give the safety aspects to the workers. We need to give proper training. We need to assess the risk, what it will happen to the worker. How we can assess the risk? So the risk assessment is based on the tool what the current scenario is having for the workers. There is a lot of tools that is available for the workers. Nowadays, the artificial intelligence technology for the workers is based on the band, workers band, right? So like watches, like smartwatch, what we are using now. So based on that, a programming will be written in a small chip. It's like a wristband. So we can wear it in the forehand, right, in the wrist place. So every labor, he needs to wear that. So based on that, the chip, if it is, it's like a pulse checking, right? So based on that, we can able to get the output of every labor, his heartbeat, his whether he is like distress or he is normal. The both normal and abnormal condition, we can able to check it. That's all. It comes under the risk assessment, right? So in the disaster management, the risk assessment plays the vital role, whether the land will be subjected to disaster or in how many years the land will be safe with respect to the disaster. Like that, before prediction and all, we can able to make it through the risk assessment. And after risk assessment, there is a early warning system. Like in the seashore area, there is a the people are giving the continuous thing, right? Now tomorrow you should not go inside the sea for fishing and all, because tomorrow there will be a huge tides will come. So like the government is giving the pre-warning, right? So based on that, AA2 also will give the pre-warning that is called early warning system, that you should not go do like this, or there is a subject of landslides, or there is a subject of flood, or there is a subject of seismic activities like that, right? And after early warning system, for example, there is a case studies available that rainfall data and river levels, we can able, that I will show in detail, where we can able to predict the potential flooding, right, allowing for timely evacuation. So for example, if the damages seems to be happened, for example, if the earthquake seems to be happened, how much time it will we can have to evacuate or rescue the people from inside the building or some other places, right? And damage assessment, we can able to make well in advance. For example, if we are using the proper artificial intelligence tool in the scenario what we are going to implement, so that we can reduce the damage. Compulsory, if we are using the artificial intelligence, we will not assure that there will not be any damage. If we are implementing the artificial intelligence like deep learning technique or machine learning technique, somewhat we can able to predict and we can reduce the damage that is going to happen in the particular area, right? So further, we can able to use the tools called XView tool, AI tool, which will have the satellite imagery, which will identify and it will prioritize or categorize the building and its damages level, right? So after that, it will move to the situational awareness. So as I already pointed that the situation will not be same for all the sectors in the same domain, I'm telling, right? For example, in your locality, if you are constructing the building in two places, whether you can tell the same type of prediction will be there, it will not be. Surely it will not be, right? So the situational awareness will be different for the different places, right? So finally, the communication and coordination, as I pointed, and the best case study is the Turkey-Syria earthquake, right? Next slide, please. So what are the types of artificial intelligence tool that we can use in disaster management? So in the earlier slide, I have pointed the concept map or the flow map, which will target from the mitigation and ending with the communication and the coordination, right? So in between, it involves that early warning system, response behavior, and many things. How we can arrest the damage or how we can reduce the damage, how based on the risk assessment like that. So it is a very vast area, or it is a very new area to the civil engineering point of view. But in the artificial intelligence, like data sciences, computer science and design, these people nowadays, mechatronics, they are very well versed using these kind of artificial intelligence tool for the manufacturing the machines or electronic components, etc. But for civil engineering, it's a very new tool where the augmented virtual reality plays a vital role in current days, right? So the first thing, types of AI tool in disaster involves the machine learning, deep learning, NLP, which is called natural language processing, and finally the computer vision, right? These are the common AI tool or basic AI platforms where the AI code will be developed for the disaster management, right? So starting, I will explain you in a glimpse that what is meant by machine learning. So there is a book called, if you are more interested to know about the machine learning, actually uh, there is an NPTEL course on machine learning for the beginners, right? So if you are more interested, you people can go through that. Just a minute, please. So am I audible, right? Am I audible, right?
Yes, sir.
Okay. So if you are more interested, I can give you the best NPTEL tool, because the machine learning is, I already pointed, this is a very needed for all the domains, now for civil engineers also. I think in the 2025 NPTEL, they are going to teach about machine learning for the beginners, right? So I request you people to go through that NPTEL also. So the machine learning, it's based on the algorithms. We will develop the algorithms, and based on the data what we are using for the data set, and it involves the applications like predictive modeling, risk and damage assessment. In the machine learning, what we are going to do, right? It is it's like a big data set, right? It's a larger data set where what is the difference between machine learning and the deep learning? Deep learning involves, it is a subset of machine learning, right? Group of ML is called DL. Like that, we can able to tell. So it is a DL is a vast technology. In that DL, there will be a subset of ML. right? So, in a simple way, what we can tell now, we are going to train the machine. For example, if you are telling that I am not able to understand, sir, what it may be training of machine means. Again, I am coming to the example of 3D printing, right? There will be a robot and there will be a system, computer, and there will be a mixer machine. I will give you three aspects or three uh, material or machines. One is 3D printer or robot. Second thing, a system or laptop. Third thing, mixer machine. In the 3D printer, there will be a rotary will be there or blade will be there, right? Which will mix the concrete mix what we are giving. So what is the system it is doing? In between 3D printer and the mixer machine, in between the system that it is there. It is a computer is there. What the computer is doing? It is connecting the target with the robot. Our target level with the robot. What is our target level? We need to construct a building. How we can construct a building? We are train the robot through the system, right? Simply without the system, the robot will not function. We need to make the program based on our target, and if we are embed the targeted program in the system, it will function and it will give the direct output what we are able to expecting, right? So that is called machine learning. We need to train the machine, right? So deep learning technique involves, as I already pointed, it is a subset of machine learning, which will have the artificial networks, right? So I will simply give you an example. Please understand clearly, x plus y equal to z, right? X plus y equal to z. What is meant by that? Machine learning or artificial neural network or etc. X plus y equal to z means assume that x is the input parameters, z is the output. Say for example, z is the compression strength, right? You are in the position that assume that you are a construction engineer. You have been allotted with the task of constructing the building in the zone 5, where there is a more disasters, right? You need to use the, it is not enough if you are simply using the IS 456. You need to use IS 875 part 4. You need to use IS 1893 to check the base shear. You need to use IS 13920 for ductile detailing to make strong column and weak beam concept. And you need to use IS 4326. The basic code I'm telling. So for that, it is a hybrid technology where concrete and steel, we need to use club together, right? So my point is, there is a code called IS 10262. We well aware of it. It is the construction, that is mixed design code practice. There is two important terms they have pointed in the Indian standards, not only in Indian standards as well as in American Euro standards. It is characteristic strength and target strength. So you are, as I already pointed, you are the construction engineer appointed in zone 5. You need to construct the building, right? So you need to make a concrete to be very strong. At that time, you should not go for lightweight technology. That is, as I already told, that less than 1000 kg per meter cube. Because the density will be very, very less. It is very difficult to take care of the load. That is dynamic load. So what you will do, so you will make the target strength to be in a higher level, right? X plus y equal to z means x is the input parameter I already told, z is the output, that is the character target strength. Intermediately y is there. What is meant by y? If x is changing, that is x means let it be x1, x2, x3, x4, x5. X1 means cement, x2 means sand, x3 means coarse aggregate, x4 means water, x5 means admixture. Anything it may be, like gradation or non-gradation. So if you're altering or if you're training, right, with respect to y, the z will be changed. For example, see, so if you are reducing cement by 20%, say for example, if you are using 80% cement and 20% silica fume, right, the strength will be higher than if you are using 100% of PPC. I think you will able to get it. So, but I am not able to know how much Z will be unless until if I am not doing the experimental work, I will not come to know that what will be the Z. So for that, I will use the deep learning technology using the artificial neural network, that is MATLAB coding, right? There is a ant colony algorithm is there. Many tool is there. So you will train the X value and Y value such that you will get the appropriate Z value to your location, what you are going to construct the building, right? So these data sets will be available in the deep learning technique, right? So the applications will be the image analysis. Say for example, if you are cutting the concrete and if you want to see the arrangements of the pores, arrangement of the void gaps, like that, the basic concept is the deep learning technology. Object detection. Object detection means, see, nowadays in the augmented reality, right? Simply we can wear the glass and we can able to see where the position of steel is there. There is a advanced level of coding is developed nowadays. You can just simply wear the glass like hologram technology. You can able to see where is the main reinforcement, what is the diameter of the main reinforcement, what is the position of the reinforcement, whether the electrical conduits have been laid properly or not, where the leakage is there. Everything we can able to clearly check. But here, the object detection is very, very important uh, exclusively for the disaster. For example, IS 1390 is clearly mentioning that the hook distance, hook angle will be like 130 plus degree or something like that. If we are not properly giving the hook arrangement, then it is very, very difficult to arrest the earthquake, then the disaster will be heavier, right? So there and all, we can use the artificial intelligence technique. And similarly, the natural language processing, the applications like text data from social media, right? Based on the public sentiment, identification needs for the client, and gathering multi-information, not a single information. So in the startups, in the commercialization, it will be called it as a customer metrics. So based on how much data you are collecting, the accuracy will be like finite element analysis in the abacus, what we are using now, the same thing will be. If you are gathering 100 information, the result will be accurate. If you are gathering 5 information, the result will be very, very less. The accuracy will be very, very less, right? So finally, the computer vision, right? So analyzing the images and videos like based on the satellite images, based on the drone, how it is gathering the data, right? Say for example, drone data we are using for surveying, right? So without going to the field, we can stay at one place, we can fly the drone over the area, it will capture all the images like aerial surveying, then it will directly we can get the data. Based on that, we can able to plot the contour and we can come to know that what is the area will be. Next thing, please. So the mitigation comes under, as I already told, that how to minimize the major effects that is creating to the public. So the main key strategies which involving in the mitigation aspects are everything we need to make, we need to check the risk assessment, right? So what kind of risk it may be, how to prevent the risk, right? What are the, see, we can somewhat prevent the risk, but we cannot completely stop the risk. Why the breathing time is given means at that time we can rescue the people, right? So infrastructure strengthening, right? So we can classify into two types, RCC, in zone 2 and RCC in the zone 5. So we need to, if it is in the zone 5, we need to make the horizontal band connecting the wall to wall, right? Like V-shaped band, all the corners of the wall or all the corners of the joints of the building, such that to make the homogeneity, right? Environmental protection, like preserving the mangroves and forests, right? So giving the early warning systems, like leveraging artificial intelligence to develop systems for timely disaster alert. As I given an example, right? Tomorrow, if there is a high tides is coming in the sea, the government is giving the alert to the fisheries. You should not go inside the sea because tomorrow the atmospheric condition is not good. Like it is an early warning system, right? So these and all comes under the mitigation where the Google Flood Hub, they have developed the coding for 80 countries for predicting or forecasting the floods. Next thing. So in detail, you can able to see the example of flood curve, which was pointed for the South India, exclusively the Tamil Nadu, right? So you can able to see the positions of flood and which was marked in the Google map, right? So which will help the communities to be aware of the flood, how to save lives, and main important thing, reducing the economic losses. So take example of Turkey, right? So last year, the huge disaster was happened, right? Heavy earthquake was there. So much of disasters, the intensity, the magnitude of earthquake was also higher, as well as the intensity, the damage level also was higher, right? So somewhat we can able to see there is a seismoscope, everything is there, but we need to be very cautious in developing the AI tool, selecting the AI tool which will be very appropriate for the disaster management. Right. Next slide, please. So after completing the mitigation, next thing we are going for preparedness in the disaster management sector, which will have the actions taken to ensure the readiness for effective response to disasters. Right. So what are the actions we have taken? What are the steps we have taken? So what are the key components it is involving? Like in the previous mitigation sector, we have gone through that early warning system, right? For giving the timely alert. And based on that, we need to make the resource allocation, right? Say, for example, a resource allocation means, I will give you one example. After disaster, the government is asking to have the fund for bringing back that particular area into original position. Means the state government is asking to the central government that this much amount we need. Say, for example, Wayanad, the Kerala, they have asked so much of crores to the central government in order to bring back the system to the original condition. How they are claiming, in what ways they are claiming. So if it is comes under natural disaster, the fund allocation will be higher, right? So say for example, how we can allocate the resources for preventing the disasters. For that, artificial intelligence tools will optimize the distribution for the critical supplies and the personnel, right? And giving the proper community training, right? So this training aspect is very important because international safety forum, what they are telling now, without giving proper training to the administrative people, we can't able to manage the or control the disaster. Not only controlling the disaster, giving the proper safety aspect to the personnel. Ultimately, every audit will happen only for the particular administrative people and they will inquire with the workers whether the administrators have given the proper training to the workers before starting the work. It's like a pedagogy training, right? And final thing is the emergency plan developing, which will involve the developing and testing action plans for various disaster scenarios. So in this, what is the algorithm platform it is involved is the unit, right? So it is contributing mostly to the risk assessment and the reconstruction prioritization, whether we need to make the reconstruction or we need to something alternative. So how we can select the alternative technology based on the risk, right? It is called reconstruction prioritization. So it will be mostly held by the unit algorithm, right? Next thing, please. So unit algorithm, it is one of the deep learning model which consists of the subsets of machine learning widely used in the disaster area, where the key features, the primary features is the analyzing the satellite or aerial imaginary images, where you can see in the bottom photos, three different photos have been taken by the satellites or aerial images. One is before disaster and another is post disaster, where you can see the disturbances and the casualties which is taken. We can observe from the images, right? So based on that, the scaled map is drawn or scaled map is explored. The result of fusion model. It is obtained from the unit. So we are currently doing one project with the computer science and computer science department. So our ultimate, it is not related to disaster, but it is related more to identification or sorting of the construction and demolition waste, right? So the same image will come, like what you are seeing, the result of fusion model, right? The same image we are getting, right? For example, in construction and demolition industry, we can't get only the concrete, right? It will be a fusion of concrete, it is a fusion of ceramics, it is a fusion of wood, it is a fusion of bricks, mortar, it's a fusion of steel, right? Everything it will come. So how to identify and how to reuse the technology. For that, we are using a different correlation platform machine learning algorithm, right? So it will scan the construction and demolition waste and it will identify which is the concrete, which is the steel, which is the brick, and what is the usable ratio, and what is the presence of concrete, what is the presence of the, how much presence of concrete is there, like that it will give. So how it is given? So we are training the system by taking more photos, right? So for example, if it is a gray color, it will conclude this is the concrete. If it is a dark brown or a higher wavelength output, it will classify as a steel. So the resemblance will be either dark brown or a black. So based on the illuminance level or the reflection level of the material, the system will classify different types. So you can see in the third photo result of fusion model, the first and second, it is a whiter and gray image, but in the third model, it is a red, right? So it is the predicted model, right? So it identifies and segments area of interest, for example, which is the flood zone, which is a damaged building, like that. And it provides high resolution mapping, like contour mapping, what we are doing now during the surveying, either by total station or either by pure lake surveying or whatever it may be, right? So like that, it is similarly give the high resolution mapping for precise risk assessment and recovery plan. So based on that, we can able to come for the decision making, whether we can go for reconstruction or we can somewhat make the alternate arrangements. Next thing, please. So the applications in the disaster management is classified into the building segmentation result and building damage detection result, right? So it involves the risk assessment reconstruction prioritization, and very, very important thing, the damage analysis, right? So which will involve the facilitates accurate and timely damage assessment for the resource allocation, right? So the benefits involves the accuracy level. Like if we are using the StatPro and if we are using the finite element modeling, right? We obviously say that finite element will give the accurate meshing, right? Disintegration, right? So how much finally we are meshing and how much we are getting the behavior of the specimen, like RCC specimen, right? So, for example, if the span is 3 meter, if we want to have, if we want to know the deflection at 0.36 meter from the support, we can able to get it accurately, right? So, how it is getting the accurate result means we are disintegrating the structure into different meshes, right? So, the accuracy level will be very higher. Faster analysis compared to the conventional method, right? Integration with other AI tools for comprehensive disaster responses. So these are the some benefits and applications based on the unit-based algorithm, right? Next thing, please. So responses, third thing we are coming to the response after mitigation and the preparedness, we are coming to the response. The response means every action there will be a reaction, right? So what material if you are giving, based on the quality or the nature of the material, your response will be, right? So the phase of the disaster management, which will focus on the immediate actions. What are the actions to save lives, reducing from suffering, and mitigating for the further damage, to arrest from further damage. For example, in one place, if the earthquake has been happened or flood has been happened, we need to take proper steps based on the response based on the previous response, and based on that, we need to take clever action to avoid from the further damage, right? So it involves the situational awareness based on the real-time data collection, right? Communication and coordination between the responders, resource deployment, right? That is by rapid or quick allocation of the resources for flood, water, and medical supplies, rescue operations. Right? If the damage happens, without wasting the time, how fastly or how rapidly we can secure the people or the associated lives in the disasters. Take for example in Wayanad, it's a heavy clay area, right? Some people they have found very difficult to rescue the people, right? So say for example, if the earthquake is happened, there is a one advanced technology called cockroach theory, right? What is the cockroach theory means? The cockroach, it's a very small insect where it will contain the filament, right? It is called antenna. It is a very flexible device. It's not an original cockroach. It is a developed cockroach. It's like a robot, which is in the size of cockroach. So they are using a nanotechnology embedded the circuit in the skin of the cockroach, the body, right? It will enter inside the earthquake-prone, earthquake-affected buildings. After the earthquake happened, many buildings will get collapsed, right? The cockroach will go inside the damaged building. It will see and it will capture the data where the humans has been identified or humans are present. And the data will come to the cloud, and the original people, those who are operating the cockroach, right? He will come to know that this place, the presence of life is there based on the frequency communication, right? So it will help the rescue team to go there and rescue the people to hospital or something like that. So here in the last preparedness, we came to see that the unit algorithm. Here we are going to see the XFute AI tool, which will help the satellite imagery to identify and categorize building and the infrastructure damage, how much damage it will happen. Next slide, please. So these are the some of the key features of the XView AI tool, which was developed by the Pentagon and Carnegie Mellon University in Pennsylvania in US, right? So they are using for damage assessment post disaster. You can able to see the three images as we have seen for the preparedness level. In the pre-event image, it is the raw image before the disaster happened. And in the post image, you can able to see how flood has been covered the agricultural area, right? And you can able to see the location mask, the presence of buildings, the presence of damages, the affected areas, and there is a scaling ratio where you can the dark blue which gives the background and the green which will give the no the area is not affected by the disaster or flood, and the minor damages is given in the orange scale. Like in the answers, we will get it right. Say, for example, if the stress is more, it will be given in the different colors, right? Starting from the major scale to the minor scale. Like that, the mapping has been plotted using the XView AI tool, right? Next slide, please. So the benefits, the applications, it's a very rapid, similar to unit algorithm. It helps for the resource allocation and recovery planning to the NGOs. And the benefits are it saves time, enhances accuracy, and support decision making. Quick decision making is very essential, or it will be more helpful using the XView AI tool, right? Next slide, please. So we have seen the three aspects, that is mitigation, preparedness, and the response. Here, the fourth aspect is the recovery, which involves the process of rebuilding or restoring infrastructure. As I already pointed, that if building has been damaged, so our ultimate objective is to bring back the building to the original condition or the restoring to the original condition. How we can bring back the services, livelihoods, etc. after the disaster has been happened, right? So it is the sole decision by the engineer or the administrator to make the decision how we can restore the building. So here some of the objectives involve the needs assessment based on the long-term requirements of sustainability. Infrastructure restoration involves the rebuilding damaged roads, whether the roads has been damaged in the joints, construction joints, bridges, utilities, and some of the buildings, operating buildings. The economic recovery, right? Reviving local economies, that is bringing back and providing support for the commercial aspects, right? So psychosocial supports involves assisting communities with the mental health and the social well-being, right? So the prioritized actions, which involves the disaster situation, the location of the survivors, that is survivors means who are all the people still having the life. Say, for example, if they are affected by the earthquake or flood, whether they are still live or alive, right? So what is the infrastructure damage and what is the type of hazards? It will be more useful based on the recovery aspect in the AI tool. Next thing, please. So at the outset, the benefits of AI in disaster management is improved accuracy and speed, enhanced situational awareness, efficiency increasing for optimized resource allocations and streamlining the communication, reduce the response time, right? So if we are reducing the response time, we can save much people, we can save the economy, right? The amount will be saved. And enhance resilience, right? Based on the past lessons learned from the past events, if we are developing the current scenario, we can able to safeguard the future, right? Next thing, please. So we need to keep the ethical considerations, right, in the mind. for developing the AI tool for the disasters by considering the cultivating trust, that is building the faith in the AI systems, whatever it may be. If you are using Unit or if you are using XView or if you are using Google Flutter, whatever it may be, the building trust is more important. So based on the building trust only, the output what you are getting, you can able to justify or you can able to study or analysis. Based on that, you can able to implement the same in the sector. The privacy and data security is very important to collect and analyze the sensitive personal data. So if the data what you are using in the set of systems, say for example, if you are using a deep learning technique in the subset data, all the data should be ethical, right? You should not randomly assume the data. If you are assuming the data, it should based on the reference. Either it may be with respect to the past history, or it may be with respect to the Indian standard or something model basis, right? And the bias and discrimination, there should not be any bias and discriminations in making the AI tools for the management analysis. It should be a transparent and accountability, right? The output what we are getting, it should be a transparent. If the transparency is there, then only the decision making will be fruitful, right? So how the transparency will be there? If you are using data in a proper way, say for example, it is not necessary to go for much data. I earlier told that if you are using much data, the result will be good. So if the data is not sufficient, the data what you are getting is original, it will be more okay for or more helpful for making the decisions, right? Human oversight is very crucial or important or significant, which will ensure that AI systems are using for responsibility actions, right? Next slide, please. So what are the challenges, right? What are the limitations and challenges? That is allowances. So for data quality and availability, so based on the data quality and availability only, the decision making will be proper. Bias and discriminations, as I already point. Trustworthiness, ethical considerations, as I pointed in the earlier slide, and finally the cost and infrastructure. So if you are using much legal data, we can able to reduce the cost incurring for the restoration of the infrastructure or the damaged sector, right? Next. The future of AI in disaster management, this is a problem gap analysis. If you are more interested to do, this is a good slide, I think. For increased integration using the blockchain technology, improved prediction and prevention, right? So the advanced AI technology will help to give more accurate prediction and the prevention aspects. So as I already pointed, we cannot completely avoid from the disaster. Somewhat we can able to rescue the people in a mature way, right? Spatial intelligence, right? For essential GS mapping, right? So identifying the disaster prone areas, identifying the vulnerable populations, right? So enhanced response and recovery, as I pointed earlier. So helpful for the public health during the emergencies, and very importantly, human-centered AI, which will prioritize for the human well-being. So these are the future of AI in the disaster management. Next slide, please. So as I pointed earlier, many platforms, the Google Flutter, they are using. So if you want to write paper or if you want to submit a research proposal, you can related to the artificial intelligence in disaster, right? Either to the science and technology DST or something like that. You can try up with the basic modeling of the Google Flutter, right? As a primary tool. Next thing, please. So this is the rainfall data, one primary example, how they are using that from the left to right, starting from groundwater, how the storage of runoff water is there, how it is using for the grass, how much crop will be developed based on the stored data, stored water, right? How it is transmitting to the industry for the manufacturing, and how the wastewater is again dumping into the uh, river water, right? So obviously we know that the salinity will get changed, right? So if the fresh water is get mixed with the wastewater, the salinity will get changed, right? So there will be a difference between the pH and hardness, right? So this is a chain loop, so which was developed in the aquascope, right? It is again it is a AA tool, right? Nowadays the electronic and communication people, they are mostly studying the soil level humidity. So it is very good topic. They are using the humidity probes to check the water, that is moisture content in the soil. So the main purpose is to how much water we can use it for cultivating the crops without using much water or without wasting the much water for the crop cultivation. Initially, if you are using the probes for humidity probes or moisture probes for studying the soil condition, so we can get the much data, and we can able to use the drones also. So the drones will help the surveying of the land, and the aerial image surveying will give to the administrator. So administrator will have the aerial image map as well as the humidity meter. So from that he will able to know how much water he needs to use for this particular land. So this aquascope is much more a usable platform where you can control from your mobile itself, right? It's based on the IoT technology. Next thing, please. So XView challenge, you can, as a researcher, if you are a very beginner, uh, you can able to use the XView tool to check the damage level aspects. You can simply take one project and you can use this kind of XView challenge technology, and you can get the output, what is the response is, right? Next thing, please. So the here the slide show that the new technology for the drones and satellites, which will have help the where you can see that right side photo, the markings are happened. The red color markings are affected much more area, right? Which is destroyed by the earthquake in the place of Turkey and Syria, right? WFJ's Georgetown is the place, not the place. It is the one person name. Explore some of the mapping text that secures uh, have at their disposal, right? So he has point on technology, how to mitigate the uh, problems that is occurring to the disasters, right? For rescuing of the workers. Next thing, please. So in the conclusion, it is AI is the powerful tool which will for starting from mitigations, then for preparedness, then for response, and finally to the recovery. These are chain loop where you can use the uh, unit algorithm based on the machine learning or deep learning technology or NLP or computer vision, whatever it may be. So you can implement the same, and you can develop this for any of the projects, not only for disasters, for your research aspects also. Uh, it is which will help to save lives, rescue people, resource allocations, right? And it is an ethical application and fully realized for the transparent potentials for the disaster management. So next slide, please. So these are some of the references which is very useful for the uh, people, those who are really interested with artificial intelligence and disaster management, right? So thank you so much. I think I have given some of the basic inputs related to artificial intelligence, and hope it was useful to you people. Thank you. So, any questions? Uh, audible, right?
Yes, sir. Audible, sir.
Okay. So, if you people are having any questions, you can able to. So if there is no questions, I think thank you so much once again for patience listening. I once again thank the coordinators, Dr. Shanmugam sir and his team for providing me the opportunity to discuss the upcoming technology, which is very essential for the current scenario. Thank you once again.
Thank you, sir. Clearly connects the latest technology AI with the civil engineering field disaster management. Different types of AI used in this area. Through Google Hub, with the help of AI, we can get connected to the disaster related information 7 days well in advance, so that lives and properties can be saved in the future. And future of AI in the field of disaster management is also covered. Thank you so much for your wonderful section, sir.
Thank you, man. Thank you so much. Shall I leave?
Yes, sir.
Or do you want to take any screenshots or something for your attendance? Or?
So already taken, sir.
Okay. Okay.
Let me share the feedback form right now, sir.
Okay, ma'am. Okay. Thank you so much, ma'am. Thank you.
Thank you, sir.
Thank you, participants. Thank you.
Participants, kindly fill the feedback form right now.